Hello students, so let's start discussion of test 91. Overall paper is on very easy side. I would say 155 plus is a good score. So overall 34 questions are on easy category, 7 are in medium difficult category and 4 are in difficult category. So let's start from question number 1. A hydrogen atom makes transition from N1 to N2. The time period of electron in the initial state is N times that in the final state. So it's given that T1 is 8 times T2. Okay, so now time period is 2 pi r by V, so proportional to r by V. R we know proportional to n square and V we know proportional to 1 upon n, so proportional to n cube. So n is proportional to t to the power 1 by 3. Okay, so n1 upon n2 is T1 upon T2 is 8, so 8 raised to power 1 by 3, that is 2. So we should choose the option where N1 is 2 N2. So A is the correct option, N1 is 2 N2. Alright. Now let's move next question. Ionization energy of 10 times ionized sodium atom. So ionization energy of an atom having atomic number Z, hydrogen-like atom having atomic number Z, is Z square E naught, where E naught is ionization energy of hydrogen atom in ground state. Now Z is 11 for sodium, so 11 square E naught, and E naught is 13.6 eV. So correct option is 13.6 into 11 square. Small block moves with velocity 5 towards another block of same mass at distance 2 meter. Coefficient of friction this. The collision is elastic. The separation between the blocks when both of them come to rest. So guys, both the blocks have same masses and they undergo elastic collision, so their velocities will get exchanged, and we have to calculate separation between the blocks when both of them come to rest. Okay, so capital M mass start from O with speed u, and this capital M another mass is at rest at 2 meter distance. Okay, now say capital M collides with another capital M with speed v1. Now velocities get exchanged and the first block comes to rest. Suppose this is A, this is B. So A comes to rest and B start moving with the same speed V1, and finally B comes to rest. Okay, finally B comes to rest, A comes to rest, B starts moving and B comes to rest. So this is the separation which we need to calculate. So the situation is as though B is throughout at rest and A is continuously moving. So stopping distance for A, V square is U square plus 2AS, V is 0, U square is 5 square plus 2A minus mu G, minus mu which is 0.25 into G which is 10 into S. So 25 upon 5, so S is 5 meter. So this complete distance is 5 meter. So D is S minus 2 which is 3 meters. So A is the correct option. Two identical spheres lie on a smooth horizontal circular groove at opposite ends of a diameter P. P is projected along the groove at the end of the time T impinges on Q. So at T equals 0, P is launched, and at time T it hits Q. If E is the coefficient of restitution, the second impact will occur. Okay, so this is the circular groove. This is a circular groove, and suppose P starts from this point with speed u, Q is at rest. Okay, so time T is a relative distance which is pi r upon relative speed which is u. So this is the time taken. Now when P and Q collide, okay, so Q and P now collide and they separate. Okay, and they separate. So we, for the second collision, we need to calculate relative velocity. So relative velocity of separation v21 is E times u12, that is E times u. So second collision will occur, relative separation 2 pi r upon relative speed which is eu. This is time for second collision. Now pi r by u is t, So this is 2t upon E. We need not calculate V1 and V2. See, relative to Q, P will travel 2 pi r distance and collide with Q. So the relative displacement is 2 pi r. Relative velocity from Newton's law of collision, relative velocity of separation is E times velocity of approach. So we need not calculate V1 and V2 separately. We need relative velocity. So relative velocity of separation is E times relative velocity of approach. So V21 is E times U. Okay, now that relative displacement, which is 2 pi r, upon relative speed, which is EU, so that is 2t by E. So D is the correct option. Stone is tied at the end, it is whirled in vertical circle at constant speed. Mind you, speed is constant and the tension in the string 6 Newton when the stone is, okay, halfway, bottom of the circle, top of the circle. So let's check, let's assume that tension is at, let's say string is at theta angle. So T is acting towards the center of the circle, mg is downward, and circular motion equation T minus mg cos theta is equal to mv square by L. So T is 6 Newton, mg 10 cos theta, mv square 16 by 1. So cos theta is -1, so theta is 180 degree. That means it is at the top of the circle. So A is the correct option. Magnetic dipole moment is deflected to 30 degree from the magnetic meridian. The required deflecting torque. Okay, so BH is in this direction and magnetic moment is in this direction. This angle is theta. So the torque due to the magnetic field, is BH m sine theta. So this is 0.4 into 10 to the power minus 4 into half into 2. So this is 0.4. So this torque mu cross B, magnetic field torque, acts in this direction. So we need to apply external torque in this direction. So external torque required is same as torque due to magnetic field but in opposite sense. So answer is 0.4 into 10 to the power minus 4. So A is the correct option. Meter bridge is used if the wire is replaced by another wire of same material but with double the length and half the thickness. So R is proportional to L by D square. So R dash upon R, length is doubled and thickness is half. So resistance has become 8 times. So balancing length will also become 8 times. So 8L is the correct option. All the edges of a block with parallel faces are unequal. Largest edge is twice the shortest edge. So let's say this is the cuboid. Okay. So this is a cuboid. Say this is smallest edge A, this is intermediate B, and this is C. All right. So R maximum is rho, length should be maximum, so this should be C, and area should be minimum, so AB. And R minimum, rho, length should be minimum, so this is A, and area should be maximum, which is BC. So R max upon R min is C upon A whole square. Now maximum edge is twice the shortest edge, so this is 2 square, so this is 4. So 4 is to 1. So maximum to minimum resistance is 4 is to 1. Okay. If V and U are electric potential and energy density, so electric potential V at a distance small r is kq by small r, and energy density, which is half epsilon naught E square, which is half epsilon naught kq by r square whole square. So U is proportional to 1 by r to the power 4 and V is proportional to 1 upon r. So U is proportional to V to the power 4. So graph between V and V4 and U will be a straight line. So C is the correct option. The minimum value of effective capacitance. So when all the three capacitors are connected in series, 1 by C is equal to 1 upon 1 plus 1 upon 2 plus 1 upon 4, which is 4 plus 2 plus 1 upon 4. So C minimum is 4 by 7 picofarad. Okay, so A is the correct option. A coil of radius R has self-inductances. Self-inductance of coil with same radius and 500 turns. So self inductance is proportional to n square, so L dash upon L is 500 upon 600 whole square, that is 25 by 36. So L dash is 25 by 36 into L, which is 108 millihenry, so that is 75 millihenry. So B is the correct option. Low loss transformer, so we should ignore the energy loss. Okay, low loss transformer, that means VPIP is equal to VSIS. Now we need to calculate VP. So VS, which is 4.6 into IS, which is 5 upon 230, so this is 1 by 10. So the current in the primary is 0.1 ampere, so A is the correct option. If the radius of earth is r, then the height at which the value of g becomes 1/4, so g dash upon g is r upon r plus h square, and that is 1/4 r upon r plus h square. Okay, so r upon r plus h is equal to 1 by 2, that means h equals r. So B is the correct option. If the depth d at which the value of acceleration in gravity becomes 1 upon n, so we need to calculate depth d where acceleration is 1 by n times the value at the surface. So we know that g at any depth is g on the surface 1 minus d by r. Now we want this to be g naught by n, so 1 minus 1 upon n is d by r, so d is n minus 1 upon n into r, so n minus 1 upon n into r, so C is the correct option. The spectral energy distribution of the sun has maximum at 4753 when temperature is this. If the temperature of star for which maximum is this, so from Wien's law, lambda sun T sun is equal to lambda T, so capital T is lambda S, which is 4753 upon 9506 into 6050, so this is 2, so this is 3025 Kelvin, so A is the correct option. For an adiabatic process, the relation between UPV is this, the gas is, so U is 2 plus 3 PV, so delta U, so U, which can be written as 2 plus 3 nRT, so delta U is 3R into N into delta T. So CV is 3R by 2. Now if F is the degrees of freedom, so FR by 2, so degree of freedom is 6. Okay, so degree of freedom is 6, so this is neither monoatomic nor diatomic. Monoatomic has 3 degrees of freedom and diatomic at low temperatures 5 degrees of freedom, so this is neither monoatomic nor diatomic, so C is the correct option. Pressure P, volume V, T of a gas in jar A, another gas 2P, V by 4, 2T, the ratio of number of molecules J. So number of molecules N is PV upon RT, so proportional to PV upon T. So this is number of moles. Okay, so number of molecules and so number of molecules PV is equal to N, which is number of moles, into RT. R can be written as K into Na, so this is capital N KT. So capital N is proportional to PV upon T, so Na upon Nb. Now pressure in A and pressure in B, so A is pressure in A is half of pressure at B, so half. Volume in A is 4 times volume of B, 4 times, and temperature in A is half of temperature of B, so that is 4:1, so D is the correct option. If the steady current I is established in the wire as shown, the loop will. So guys, this suppose this loop is PQRS, so PQ will be attracted towards the wire, okay, F on PQ, and RS will be repelled from the wire, F on RS. So net force will be towards the wire. So move towards the wire. C is the correct option. A magnetic needle lying parallel to a magnetic field required W works to turn it through 60 degree. Okay, so we know work done is MB cos theta 1 minus cos theta 2. So this is W equals MB cos 0 minus cos 60, that is MB by 2. Now torque is MB sine 60, which is root 3 by 2 MB. Now MB by 2 is W, so this is root 3 W, so A is the correct option. Body covers 2/5 of the total distance with speed this and 3/5 with speed v2. The average speed of the body will be. So let's say total distance is S. So V average is total distance upon total time. So 2/5 of the distance with speed v1. So 2s by 5 with v1. So this is the time, and 3s by 5 upon v2. This is the time for second journey. So this is s cancel. So this is 1 upon 2 by 5 v1 plus 3 by 5 v2. So this is 5 v1 v2 upon 2 v2 plus 3 v1. So correct option is 5 v1 v2 upon 2 v2 plus 3 v1. A is the correct option. From 10-meter high building, a stone A is dropped simultaneously, another stone B is thrown horizontally. So both the stones have initial velocity 0 in vertical direction. UA y is equal to UBY is equal to 0, and AAY is equal to ABY is G downwards, and delta YA is equal to delta YB is height of the building. So in the Y direction, all the three parameters are same, so time taken will be same. So both the stones will reach the ground simultaneously, so B is the correct option. The mass M is given, force is given. If it starts from rest origin, what will be the position at t equals 5 seconds? So R vector is R initial vector plus U vector t plus A vector half A vector t square. R initial is 0, U vector is 0, so half A vector t square. So half F is 10I plus 5J, and mass is 0.01 kg, and t square, that is 25. Okay, so this is 2500 into 5. So 2500 into 5, so 12500 I cap. Then 2500 into 2.5, so 2500 into 2.5, that is 250 into 25, that is 6250. So plus 6250 J cap meter. So 12500 I cap plus 6250 J cap. So B, A is the correct option. An elevator with mass m, the elevator is originally moving downwards, so it is moving downwards, velocity is downwards, and slows down, that means acceleration is upwards. Okay, so let's calculate the acceleration. So acceleration is v square in a distance of 25 meters. So v square is u square plus 2as. So v is 0, u is 10 square plus 2, as is 25. So 100 upon 25, 200 upon 50. So acceleration is minus 2 meter per second square. So it is 2 meter per second square in upward direction, as velocity is in downward direction. So tension is T is equal to mg effective, that is mg plus A. So m, which is 800, g plus A, which is 12, so 9600 Newton. So C is the correct option. Half-life is this: what mass of tritium of initial mass 64 mg will remain undecayed after 50 years. So 50 years is 4 times, so T given is 4 times half-life. So N will be N naught by 4, M will be, N naught by 16, 4 half-life, so N naught by 16. So M is M naught by 16. So that is 4 milligram. So mass undecayed will be 4 milligram after 50 years. The half-life of alpha decay is this: calculate the activity of 1 gram of sample. So this will involve a lot of calculation activity. So that is lambda n, that is ln 2 by T, and N is m by m naught into Avogadro number. So m by m naught into Avogadro. Calculate the activity of 1 gram of sample. So this is 0.7 mass 1 gram, and upon into Na 6 into 10 to the power 23 upon capital T, which is 4.5 into 10 to the power 9 years, and we need to convert into second. So 4.5 into 10 to the power 9 into 3600, 365 days into 24 hours into 3600 seconds. Okay, so this is the half-life in per second and in seconds, and m naught molar mass, which is 238 gram per mole, so into 238. Okay, so 0.7 into 6, that is 4.2. So 4.2 upon 4.5 into 3.65 into 2.4 into 3.6 into 2.38. First, let's settle the exponents. So 10 to the power 23, 10 to the power 23 upon 10 to the power 9, 10 to the power 11, 10 to the power 12, 10 to the power 15, 10 to the power 17. So into 10 to the power 6. This is 10 to the power 6. Okay, now let's try to approximate it. So 4.5 into 3. So this is 3 2s are 6, 2s are 12, 3s are 36, and 4s are 144. So this number will be greater than, of course this number will be greater than 144, that is 1.44. Okay, so let's take this number 4.2 upon 1.44 into 10 to the power. So this is 4.2 into 10 to the power 4, and this number is 4 3s are, see I have taken the lower side, 4 3s are 12, 2s are 24, 3s are 72, 2s are 144, but of course this number will be greater than 144. This number will be greater than 144, say 2 3 in between 2 and 3. So this should be around, this should be 4 point, so this should be less than 4.2 upon 2. So the only option is 1.235. So this way you can only calculate, otherwise the exact calculation will take a lot of time. I would advise you to leave the question instead. So this is 1.235 into 10 to the power 4 dps. Just try to approximate it as much as you can, otherwise leave the question. We can't afford so much time in calculation. So now let's take the next question. A tunnel is made across the earth of radius capital R. Passing through its center, a ball is dropped from a height h. In the tunnel, h is very small. So speed acquired will be very small. The motion will be periodic with time period. Okay, so this is the earth. Okay, and we have tunnel. So this is the tunnel, and ball is dropped from height h. Okay, so from O to A, time taken will be root 2h by g. A to B, motion will be simple harmonic, and then again it will move to O dash, which is h from energy conservation. So total time taken will be 4 times root 2 h by g, that is for O to A to O, B to O dash to B. So 4 times root 2 h by g, and the time period of the motion within the tunnel, which is simple harmonic, which we know 2 pi under root r by g. So 2 pi under root r by g. So this is the total time. So 2 pi under root r by g in plus 4 root 2 h by g. 4 root 2 h by g. So B is the correct option. Two equal masses, they have equal maximum velocity. So equal maximum velocity, equal masses, spring constant k1 k2, and we are to find out ratio of their amplitudes. So Vmax is omega a, that is root k by m into a. Now m is same, Vmax is same, so a is proportional to 1 upon root k. So a1 upon a2 is under root k2 upon k1, under root k2 upon k1. So D is the correct option. An Earth orbiting satellite has solar panel of area A. Solar radiations are perpendicular, completely absorbed. So radiations are perpendicular and completely absorbed. The average force. So average force is change in momentum per second. So momentum incident is Ia upon C, energy incident upon C, and final momentum is 0. So this is Ia energy incident upon C. I is 1.4 kilowatt 10 to power 3, area 5 upon C, 3 into 10 to power 8. So this is 7 by 3 into 10 to power minus 5 Newton. So 7 by 3 into 10 to power minus 5 Newton. So 2.33 into 10 to power minus 5 Newton. So C is the correct option. So from the figure we see that since stopping potential of C is greater than that of B and A, and for B and A stopping potential is same, so frequency of B is equal to frequency of A lesser than frequency of C, and IC is equal to IB is greater than IA. So nu B in nu B equals nu A, and IA not equals IB, so A is the correct option. The extension of the spring X0 in equilibrium, so such that half submerged in the liquid, and extension X0 in equilibrium. Okay, so on the beaker, on the block, Kx force, Kx0 force acts upward, buoyancy force acts upward, and mg force acts downward. So in equilibrium, Kx0 plus buoyancy force is equal to mg. Okay, now Kx0 buoyancy force is half volume Al by 2 into density of fluid into g, and is equal to mg. So x0 is mg by k 1 minus sigma Al by 2m, 1 minus sigma Al upon 2m, mg by k. So C is the correct option. So this spring block A is submerged in the liquid. Block A is submerged in the liquid. Okay, so for block A, spring force is in upward direction, Fs1, and for beaker, spring force is, it compresses spring, so spring force is Fs2. All right, so mg, mag, and this is mass of beaker into g. Now the liquid exerts thrust force on the block in upward direction, and on the beaker the block exerts thrust force, buoyancy force in downward direction. So from figure we see Fs1 decreases and Fs2 increases. Fs1 will decrease by buoyancy force and Fs2 will increase by buoyancy force. A biconvex lens is placed in front of a mirror. So this is biconvex lens, and this is placed in front of a concave mirror at 10 centimeter distance, in front of a plane mirror, in front of a plane mirror at 10 centimeter distance, and object is placed at 30 centimeter. Okay, and focal length of the lens is 15 centimeter. So as u1 is twice of f, so v1 will be plus 2f. So image of object after refraction from the lens will be formed at 30 centimeter in front of the lens. So this will be I1, 30 centimeter image will be formed from the lens. So distance from the mirror is 20 centimeter. So plane mirror will form image in front of it at distance 20 centimeter. So this will form image in front of it at 20 centimeter. This is I2. Okay, for mirror, so plane mirror forms image at 20 centimeter in front of it, which acts as object for lens. Now for lens, u3 is plus 10 centimeter, because this total distance is 20 centimeter and this is 10 centimeter. So the distance of I2 from the lens is 10 centimeter. Okay, so u3 is plus 10, f is 15 centimeter. So now v3 is uf upon u minus f, u plus f. So 10 into 15 upon 10 plus 15, that is 6 centimeter. So final image gets formed at 6 centimeter. This is the final image at 6 centimeter. So, and this is real because actually rays converge. So what, and 6 centimeter from the lens, so from the mirror it is 16 centimeter. So real and at a distance of 16 centimeter from the mirror. Concave mirror is placed on a horizontal table with its axis directed vertical upward. Let O be the pole of the mirror and C is the center of curvature. A point object O is placed at C. It has a real image also located at C. If the mirror is now filled with water, the image will be, okay. So concave mirror, we have this concave mirror. We have this concave mirror and object is placed at its C. Okay. Now on filling the mirror with water, real and will remain at C. Now the object distance, so now the rays will come in the water. So rays will come in the water and we can go by real and located point between C and O. Okay, so 1 by F is 1 upon Fm minus 2 times 1 upon FL. Okay, now FL is 1 upon FL is 3 by 2 minus 1, 1 by R1 minus 1 by R2. So this is 1 by 2R. Okay, so focal length, now 1 upon Fm, 1 upon FL is 1 by 2R. This acts as a converging lens. So 1 upon minus R by 2 minus 2 times FL, and FL is 2R. So this is minus 2 by R minus 2 by 2R. So this is minus 3 by R. So focal length is minus R by 3. So now the focal length has reduced from R by 2 to R by 3. That means for the new mirror, for the new equivalent mirror, object lies between 2f and minus infinity. So image will form between f and 2f. Okay, so real and will remain at C. No, real and located at a point between C and infinity. Virtual, no, real and located at a point between C and O. So image will be located, real and located at a point between C and O. Since object is at distance greater than 2f, so image will be between 2f and f. So it will be close to the mirror now. So real and located at a point between C and O. So D is the correct option. See, first we have calculated focal length of the lens, which is 1 by 2R. Okay, FL is 2R. Now the focal length of the equivalent mirror, 1 by F is 1 by Fm minus 2 times 1 upon FL. So from that we calculated the focal length to be minus 3 by minus R by 3. So focal length has reduced from R by 2 to R by 3. That means now the object is not at 2f, it is between 2f and minus infinity. So image will form between 2f and f. So image will now be formed closer to the mirror. So it will form between C and O, between C and O. So real and located at a point between C and O. So D is the correct option. Uniform cube of mass m and length, edge length A moves on a horizontal surface along the positive x-axis with initial velocity v0. So this uniform cube, just a minute, this uniform cube moves in positive x direction with initial velocity v0. Okay, this is positive x direction. So friction will oppose the motion, friction will act in this direction, mg is acting at the center of gravity. Now this friction is generating torque about center of mass in clockwise sense. So the cube has tendency to topple in this sense. Because of this, the normal reaction will get shift towards the front edge to counterbalance the torque of friction. So during motion, normal reaction acts on the center. No, during motion, the normal reaction shifts towards positive x-axis from the center of mass. So C is the correct option. This is from toppling. You should understand the topic. A coin is mass m is rolling on a horizontal surface. So coin is disk with an angular velocity this, the total kinetic energy. So total kinetic energy is, either you can write half I about IOR incidence axis of rotation into omega square, that is half I about IAOR, which is half mr square plus mr square into omega square, that is 3/4 mr square into omega square. Or you can break the energy as kinetic energy in translatory motion, which is half m vcm square plus kinetic energy in rotational motion, which is half icm into omega square. So that will be 3/4 mr square omega square. And there is simple data, we can calculate it. For the circuit shown in figure, current through Zener diode. So we are given, say this is I current, this is I1 and this is I2. So we can calculate I is 70 volt upon 5 kilo ohm, that is 14 milliampere. We can calculate I2, since this is 70 volt, okay, this is 70 volt, this is 120 volt, so this should be 50 volt. So we can calculate I2 as 50 volt upon 10 kilo ohm, that is 5 milliampere. So now I1 is I minus I2, that is 9 milliampere. So B is the correct option. GE specimen is doped with Al, the concentration of acceptor atoms. So Ne into NH is Ni square. Ne into NH is Ni square. The electron hole pair, given that the intrinsic concentration of electron hole pair is this much, 10 to power minus 19, and 10 to power minus 20, 10 to power 21 is concentration of holes, so concentration of electrons. So Ne is Ni, which is 10 to power 19 into 10 to power 19, which is, and NH is 10 to power 21, so this is 10 to power 17 per meter cube. So A is the correct option. The potential energy has been shown in the joining diagram. It attracted when X lies between A and B. So B is the equilibrium position between A and B. F, which is minus du by dx, is greater than 0, which means force is repulsive. And between B and C, F, which is minus du by dx, is less than 0, which means force is attractive. Force is positive, that means it is acting outward, so it should be repulsive, and force is negative, that means it is acting inward, so it should be attractive. So between B and C, force is attractive, and between A and B, it is repulsive. And the dimensional formula of omega t plus phi naught. See, this is angle. The argument is angle, which is measured in radians, and radian is dimensionless. So omega t plus phi naught has dimension 0, m0, l0, t0. In Young's double slit, lambda 1, lambda 2, if nth bright fringe of lambda 1 coincides with, so lambda 1 capital D small, nth bright fringe of lambda 1, so n1 lambda 1 capital D by D is n plus 1th bright fringe, so lambda 2 capital D by D. So n1, so n1 lambda 1 is 780 nanometer, lambda 2 520 into n plus 1, so 26 3s are 26 2s are, so 2n is equal to 3n is equal to 2n plus 2, so n is 2, so C is the correct option. Resolving power of telescope. So resolving power is P is See, 1.22 lambda by d is a limit of resolution. So resolving power is d upon 1.22 lambda proportional to 1 upon lambda. So resolving power will increase as lambda is decreased. Focal length of IP wavelength of light is decrease. A. Two periodic waves have their sum of maximum minimum. So I max plus I min is root I1 plus root I2 whole square plus root I1 minus root I2 whole square, which is I1 plus I2 plus 2 root I1 I2, I1 plus I2 minus 2 root I1 I2. So this is 2 times I1 plus I2. So D is the correct option. Car is moving towards a cliff. The driver sounds a horn of frequency f if the velocity is in the same velocity units. Okay, so the reflected sound heard by the driver has frequency 2f. Okay, so frequency received by the cliff is f v upon v minus vc. Now this much of frequency is reflected by the cliff, which is now acts as stationary source. Cliff frequency received by the cliff. Now cliff acts as stationary source and car driver as observer, approaching observer as approaching observer. So F2 is F1 v plus vc upon v, which is f v plus vc upon v minus vc. Now f2 is 2f, so 2f is f v plus vc upon v minus vc, that is 2v minus 2vc is equal to v plus vc. So vc is v by 3. So B is the correct option. Small object is this moving in circular path. Object's velocity at an instant is 10 I cap and acceleration is this at the rate of change of kinetic energy. So rate of change of kinetic energy dk by dt is the power of the net force, which is f dot v, which is ma vector dot v vector. Now v is in I cap and a vector is in I cap as well as j cap. So this is will be ax vx plus ay vy. So m is 100 grams, 0.1, ax is 20, vx is 10, ay is 0, so this is 0, so 200 into 0.1, so 20 units watt, which is kilogram meter square per second square. So 20 is the correct option. Okay, now last question. Uniform force acts on a body this for a distance to the kinetic energy required. So delta k is equal to w, which is F into S, which is 8 joule. So C is the correct option. So that's all for today.